Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Alameda International High School. In this video, we're going to be still solving those system of equations, meaning two or more linear functions, but the way we're going to try it now is with elimination. And so what does that kind of mean? Well, what we are going to do are these following steps. We're going to write the system so the like terms with the same or opposite coefficients are aligned, and kind of make sure that we are understanding what this means. Again, like terms share the same variable. And then what does the coefficient look like? Well, let's say if we have something like 4x, our coefficient is going to be 4. If we had something like negative 3x, our coefficient would be negative 3. So you gotta make sure kind of reminding yourselves how those work. And again, we're just trying to line up those columns so that way they're a little bit easier to combine. In step number 2, it says add or subtract the equations, eliminating one variable. So what that means is this: when I rewrite, or after I eliminate one of the variables, I should just have one variable left over, meaning it should always be in terms of just one variable. Then solve the equation. So I'll have either x equals a number or y equals a number, one of those two situations. And then whatever I find out, I'm going to take that value and substitute it back into our original equations and solve for the other variable. Once I do that, make sure, again, you're getting used to that pattern of getting an x and a y value as your solution point. Again, you need an x and a y value to have an ordered pair. So for this first example, it says 4x plus 6y equals 32, and my other equation is going to be 3x minus 6y equals 3. So I already have that step 1 done. Notice how everything's kind of in its own column. And what I can do now is I'm going to say, okay, I noticed that, hey, it's already set up for us. We have some opposite coefficients with the same value. So again, I'm looking to get, a 0y right here. So the positive 6 and negative 6 are going to cancel out. So I'm just going to add these two equations together. So that means I have 7x, the y's cancel out, so I have equals, and then 32 plus 3 is going to be 35. So notice how in that step number 2, I should just have one variable left over, meaning one of these letters. In step number 3, I'm still in step number 2, so I'm trying to solve for that variable. So I need to solve for my value of x. So I have divide both sides by 7, since 7 is my coefficient. And so I'm going to say x equals 5. Again, make sure you can kind of mark off already what you have. So I have my x value for the solution point is going to be 5. So now, what am I going to do with this x equals 5? I can take and I can plug it back into my original equation. Again, either one will work, so it's up to you on which one you want to plug it back into. So I can do the first, I can do the second, doesn't really matter. So I'm going to rewrite the equation. So I'm going to rewrite this first one actually. So I'm going to say 4 and then parentheses, because instead of x, I now have 5. And I need to use parentheses to show multiplication. And so I'm going to say 4 times 5 plus 6y equals 32. So again, only thing that changed from that first equation is instead of x, I now have a 5. So again, make sure you can simplify. So I have 4 times 5 is 20. Everything else stays the same. Two-step equation, be sure you can get the variable by itself. So I'm going to subtract 20 from both sides. And so I have on the left side 6y. On the right side, I have just 32 minus 20 is 12. Divide both sides by that coefficient, so divide both sides by 6, and I get y equals 2. And so again, make sure you use both of those values to have a solution point, always in the form x comma y in parentheses. So I'm going to say my solution point, meaning where those two equations cross, is going to be at the point 5 comma 2. So again, make sure you're kind of seeing how those work. In the your turn number 1, again, make sure you're seeing how these are already lined up. So all you have to do is just combine these together. Our x's would cancel out, and make sure you're using those positive and negative integers carefully. So again, if you need to, use a number line first, so that way you can see what you end up with. So again, make sure, so check check your answer with me. All right. In example number 2, excuse me. In example number 2, we have our columns already lined up, and so we're just going to add these together. Again, notice how unless I have to, unless I have a positive or a negative value, meaning I need to have opposites of one another, I need to be able to just combine these two together. So I'm going to say, okay, since these 4 y's are opposite of each other, I'm going to say those cancel out, and then I'm left with 6x equals 36. So again, in that step number 2, after I eliminate one of the variables, I should just have 1 left over. So I'm going to divide both sides by 6, and so I'm left with x equals 6. Always in that form, x and y for your ordered pair, and so I already have half of my answer. Take that value we found for x, plug it back into your equation. So I'm going to rewrite my equation in terms of just y. So I have 4y plus 3, make sure you use parentheses to show multiplication. So I have 3 times 6, and then I have equals 22. All right. Make sure you can multiply these together. So that 3 times 6 is 18. Everything else stays the same. Again, be very mindful of what you're trying to multiply together. So I can subtract both sides by 18. Trying to get that variable by itself. So I have 4y equals 4. Divide both sides by 4, since that is my coefficient, and I have y equals 1. Make sure you write your solution to this system as an ordered pair. So we would say the ordered pair is going to be 6, 1. Okay, excuse me, same idea with your turn number 2. Again, check with me, so that way you can see if your answer is correct. So again, always in the form x comma y. Add those columns together, make sure you can eliminate, substitute back in once you get a variable, and get your second value. So now on the back, it has some practice problems, so make sure you're kind of seeing how this is set up. If you notice in number 1, again, we're trying to see if we can add or subtract these equations. So be very careful. We're saying, hey, I noticed that, the 5x and 9x, those aren't going to cancel anything out. Same with the 2 y's, they're both positives. And so what I need to do is this. I need to multiply it. So let's write like this. So I need to, if I want to subtract, that means I have to multiply each term by -1. So I'll just put it like this, by -1. You gotta be careful in this, because a lot of people are gonna mess this up. You have to make sure you're multiplying each term, not just the 2y. You have to have a -1 times each term. So what I'm going to do is this. I'm going to rewrite this second equation after I multiply by -1. So I have -9x minus 2y equals -22. So make sure you're taking your time as you do that. Again, make sure you multiply each term by that -1. Now we can combine these together. The reason why we're doing that is trying to eliminate one of those variables. So we're going to say that the 2 y's cancel out, and so I'm left with 5x minus 9x is going to be -4x. The y's cancel out, and I'm left with -16. Divide both sides by that coefficient, so our coefficient is going to be -4. So that means I have to divide both sides by -4, and so we'd say our value for x is going to be 4. Take that value, plug it back into your original equation. So I'm going to rewrite that first equation in terms of just y. So I have 5 instead of x, I have times 4 plus 2y equals 6. So I have 20, 5 times 4 is 20, plus 2y equals 6. Get that 2y by itself. Again, whatever I do to one side, got to do the other. Let me move this up here. So I have 2y equals negative 14. Again, if you're getting any kind of decimals or crazy fractions or something like that, you can be very careful, as a lot of these answers, I made sure a lot of these answers would be real simple values. So last step, divide both sides by the coefficient, and so I'm going to say my value for y is going to be negative 7. So that means my solution, or my ordered pair for this system of equations, is going to be 4, negative 7. You can always make sure you can kind of check, you can practice graphing those out on that Desmos calculator. Moving on, same kind of idea. Notice how I don't have any terms that would cancel each other out, so I need to multiply. I'm going to multiply, let's multiply that first equation by a negative 1. So I have negative 5x plus 1y minus or equals a negative 7. Now I can kind of add these two together. So you can be very careful when you're doing that. Make sure you're changing each sign for each term. So I have negative 5x, positive 7x is 2x. The y's cancel out, and so I'm left with just 4. So I have 2x equals 4. Divide both sides by 2, since that's my coefficient, and I have x equals 2. Take that value, plug it back into your equation. I'm going to plug it back into my second equation. So I have, let's do 7 times 2 minus 1y equals 11. So we're going to say this is 14 minus 1y equals 11. Get that variable by itself. So I'm going to subtract 14 from both sides. I have negative 1y equals negative 3. Make sure, so I'm going to move this up. Make sure if you have that negative value, that means that you have to divide both sides by that entire coefficient. So I have to divide both sides by negative 1 to get y equals positive 3. So you should always have, positive 1 variable equals a value. Again, whatever the value is, it has to be equal to your one positive variable. That way you can write your ordered pair like this. I'd say 2 and then positive 3. Okay, make sure you can pause, rewind, replay at any point in time for yourself. Also too, make sure you can stay hydrated for yourself. All right, so moving on to number 3. Scroll up a little bit. Let's see, do I have any opposites? I have an opposite, positive, negative 2 and 3, but make sure you're saying, again, those wouldn't cancel out, so that means I need to do this. I can take that second equation, I'm going to multiply by a negative 1 to each term. So I now have a negative 7x, positive 2y, positive 31. Combine those two together, so I'm going to say I have the 7x's cancel out, I have 5y equals, and then I have a positive 25. Make sure you divide both sides by that coefficient, so you have y equals 5. Take that value, plug it back into your original equation, and so I have 7 times, let's be careful there, again, should be in terms of just x. Gonna make sure you have 7x plus, and I have 3 times 5, since that was my value of y. Now I can have equals negative 6. And make sure you're taking your time as you write that out. So if I combine like terms, I'm going to simplify this out. So I have 15, everything else stays the same. So I have 7x plus 15 equals negative 6. Make sure you can get all the constants on one side. So I'm going to say 7x equals negative 21. Move this up here. So I have 7x equals negative 21. Divide both sides by 7, since that is my coefficient. And I can say x equals negative 3. Make sure you can plug those back into your solution. So I'm going to say negative 3 for my x value and positive 5 for my y value. You can always make sure you're writing it as an ordered pair, x and y. For number 4, I'm going to multiply the second. You can multiply the first or the second, either way works, as long as you're multiplying each of the terms by negative 1. So I'm going to do negative 2x plus 3y equals negative 11. Now I can combine those equations together to eliminate one of the variables. So I have this going to be 4x, the 3y's cancel out, and so this equals 16. Divide both sides by 4, and so I'm going to say x equals 4. Plug that back into your original equation, so I can write, I have 6 times 4 minus 3y equals 27. Make sure you can simplify, so 20 minus 3y equals 27. Try to get that variable by itself. And so I have negative 3y equals, let's take a step back. There we go. Knew I messed up here. So 6 times 4, 24. So that's what I'm going to subtract by to each side. So now I have 27 minus 24 is going to be 3. Divide both sides by that negative 3. So I'm going to say y is going to be equal to, and then negative 1. Make sure you write your solution as an ordered pair. So I'm going to say 4, negative 1. And be careful when you're taking your values. Again, those two-step equations can be tricky. But again, just like a present, you're trying to unwrap it, so you're trying to undo what has already been done. All right, last two at the very bottom, and we'll be good. So it has x and positive 5x, so those aren't opposites, but the positive and negative y are opposites. So all I have to do, I don't even have to multiply by a negative 1. I can just combine those two together. So I'm going to say 6x, the y's cancel out, and I have 36. Divide both sides by 6. And so I'm going to say x equals, make sure it's on the camera, okay, x equals 6. Easy. So I'm going to say solution at the point where x equals 6. Let's find out what our y value is. I'm going to take that value that I found for x, plug it back in. So I'm going to say, in my first equation, I'm going to use 6 plus y equals 24. Again, I don't have to multiply anything by that value of x since I just have 1x. And so I can subtract 6 from both sides. And so I'm going to say y equals 18. So let's double check. That would be 30 minus 18 is 12. So yeah, it works out for me. So I have 6 and 18. Last one, and we'll be done. Combine these two together. X's cancel out, so that means I have 2y equals 8, and that means I can divide both sides by 2 to get y equals 4. Plug it back into your original equation. Let's do the second one. So I have x plus 4 equals 1. That means I'm going to have x as a negative value, so I have x equals a negative 3. Make sure you're very careful when you write the ordered pair. A lot of people kind of switching these together. Again, take your time. Have an x, have an y, match it up. So I have my solution at negative 3 and positive 4. And super simple for yourself. Again, I can repeat those directions. Make sure that you are lining up your terms and eliminate one of the variables. Just like we've been doing, substitute that value for your variable back into one of your equations and solve for the other variable. Write that solution as an ordered pair, again, x and y. Again, be sure, check with me for your answers, and as always, super slam that subscribe button.